Okay, so let's get started with today's discussion. Today we'll be doing a full run through of Chem 100 Experiment 2, Conversion Factors and Problem Solving. First and foremost, let's talk about where to find the Chem 100 Experiment 2 lab page and where to find this lab in your lab manual. First and foremost, if you look in the Chem 100 laboratory modules for the first chapter, you'll notice that we have two labs that we're working on. Experiment 1, which we've already covered in a previous video, and Experiment 2, which is what we'll be looking at today. As always, if you click on the Experiment 2 lab page, it pulls up the Canvas lab page for this experiment, and this is where we'll find all of the data that we'll be using to fill in our laboratory report sheets. Additionally, there is also a series of lab recordings. There are recordings for Lab 2, measurements and conversion factors, and this provides a discussion of the theory behind this lab, as well as a brief review of the general concepts covered as part of Chem 100 Experiment 2. If you need any help with the calculations, I recommend checking this supplemental pre-lab lecture recording. Now, in terms of where to find this experiment in your lab manual, if you go to your lab manual, this experiment is titled Experiment 2, Conversion Factors and Problem Solving. The page numbers will vary depending on the edition and whether you have a print or virtual lab manual, but you will see this header for Experiment 2, Conversion Factors and Problem Solving, and this indicates the first page of this experiment. As always, there is a summary of the laboratory, as well as some background information on the chemical concepts covered as part of this experiment. I would encourage you, and I would suggest that you read over this background information, as it's invaluable for completing the calculations and navigating some of the theory behind this experiment. There is also some background discussion available in the Canvas laboratory page as well. So let's find now the report sheets that we'll be turning in. If we scroll down, again, as always, we have the experimental procedure, which we're going to read and go through momentarily. And scrolling further down, we have the pre-lab study questions, which you do not have to do. And finally, we're at the report sheets, the Lab 2 report sheet for conversion factors and problem solving. This is what we're going to be filling in and turning in upon completion of today's laboratory. So where are you going to turn in your report sheets? They'll be submitted in the Experiment 2 report submission page on Canvas. Okay, so I've taken this report sheet, and again, I have moved it into my digital notebook, just so that way everything's in one place. And we're going to be working through and filling in these report sheets together as we complete this lab. So let's look at part A. And the first thing that we're going to do, if we're given a table without necessarily a ton of context, let's read part A and let's make sure we understand what's happening. So a student rounded off some numbers to 3 significant figures. So in this case, we're going to determine whether the rounding was done correctly, and if it's incorrect, we'll write the correctly rounded number. Okay, so I'm going to do a few of these, as I want you to be able to work through the remainder so you can engage with the course concepts and the concepts presented in this lab. But we'll do a few representative examples. So in this case, the initial number, 143.63212. So our third significant digit would be this 3. If we're rounding, we look one space to the right. Because 6 is greater than or equal to 5, we round up to 144. This looks correct. I'm going to put a yes. Now, let's look at what happens when the student's rounded value is not correct. So let's look at this case of 8. So 8 has one significant figure. And when you're rounding, you can't really add significant figures during the rounding process. This 8 is really 8 plus minus 1, give or take. So if you add additional significant digits to 8.00, you're implying a level of precision that you haven't actually measured. So rounding 8 to 8.00, yes, this number has 3 sig figs, but our original value only had 1 sig fig, and you can never add sig figs during the rounding process. You can't get a more precise measurement after rounding. So this is incorrect. 8 would just be retained as 8, because that's the maximum number of sig figs we can report based on our measured value. I would like you independently to complete the remaining 2 examples in this table. And with that, we've completed part A. Wonderful. So let's now move on to part B. And in this case, we're just going to read the instructions. So for B1, solve the multiplication and division problems. Report your answers with the correct number of sig figs. And B2, solve the addition and subtraction problems. Report your answer with the correct number of decimal places. Wonderful. Okay. In this case, we don't need to reference the lab page. All of the data and information is available from our lab manual. We have our tables available. So let's work through these tables. So first and foremost, let's take a look at some multiplication and division calculations. So I'm going to note the number of significant digits. I'll do the first one of these examples in B1, and you'll work on the remaining 2. So in this case, this first number, this 0 is not significant. The remaining digits after the decimal place are significant. So we have 4 significant figures. 8.00, these zeros are significant. So we have 3 significant figures. These leading zeros, again, are not significant, so this last number has 3 significant figures. When you deal with multiplication and division, your final answer must contain the least number of significant figures of all of the values that you've multiplied or divided together. Thus, for 3, 3, the least number of sig figs is 3 significant digits. So our final answer will be rounded to and reported with 3 significant digits. I'm going to use a virtual calculator, though if you have your calculator at home, you'll be using the TI-30XA calculator. Let's just enter this. So 0.1184 times 8.00 times 0.0345. Okay, so we end up from this calculator string an answer of 0.032678. But we aren't done. We have to round this answer. And again, these leading zeros are not significant. So we need to find our third reported significant figure. 1, 2, 3. 6 is our third reported significant digit. If we wanted to round this number to 3 significant figures, we look 1 space to the right. And because 7 is greater than or equal to 5, we round up to 0.0327. So we'd write this as 0.0327. This number has 3 significant figures and is computationally correct. You'll complete the remainder of these examples in B1 independently. Okay, now let's move on to B2. In B2, we're asked to perform the following addition and subtraction calculations and give a final answer with the correct number of decimal places. Again, I'll do the first example as a reference, and you'll work on the later examples independently. So we have 13.45 plus 0.4552. Now for addition and subtraction, we retain the least number of decimal places. In this case, we have 2 decimal places in the first number, and the second number has 4 decimal places. So based on that, if we're retaining the least number of decimal places, we're going to retain 2 decimal places in our final answer. Adding these values together, we get 13.9052. Because we have to round this answer to 2 decimal places because we're retaining the least number of decimal places, we look 1 space to the right. 5 is greater than or equal to 5, so we round up, and that in turn gives us 13.91. Okay, wonderful. Again, you'll complete the remaining examples independently, as I want to make sure you get some practice on these concepts. So now let's take a look at part B3. So part B3, and I see a rectangle, but let's now check my instructions. So for B3, use a metric ruler to measure the length and width of the rectangle. Then we're asked to calculate the area in centimeters squared of the rectangle using your measurements and the formula of area equals length times width. We're then asked to compare our measurements to that taken by another student and calculate the area using the measurements from another student. Now, if you don't have a ruler, I have provided you some images that you can use. So let's take a look at that. So for B3, I provided you some images of a rectangle, and I've created a virtual ruler that we can use now to take some length and width measurements. And in this case, we have our centimeter ruler available, and we have our rectangle, and we have the ruler aligned for the length and width. So what we're going to do is we're going to take some measurements, and we're going to record those measurements onto our lab notebook. So we need to record the length and width, and we can do that. This rectangle is exactly the same in the lab manual and in Canvas. The only thing that's changed is we're just using a virtual ruler rather than a physical ruler. Okay, so let's take some measurements now. And you're more than welcome to use the measured values that I'm collecting right now as another student's measured value. You're going to see some variation in the measurements, and that's more than fine. Okay, so first and foremost, as I'm dealing with a ruler, to go from 0 to 1, to go from 1 centimeter, it takes us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ticks. So then we know that 1 tick mark corresponds to 1/10 of a centimeter, 0.1 centimeter. And we also know that 1/10 of a tick corresponds to 0.1 centimeter over 10, which is 0.01 centimeters. So we can estimate up to the 100ths place. Okay, so now from here, we see that we're past the 5, 6, 7, 8. So we're a little bit past 2.8. So I can measure this as 2.81 centimeters. This is going to be the width. Now let's do the length measurement. We're a little bit between 12.4 and 12.5 centimeters. So I'm going to estimate this to 12.49 centimeters for the length. Okay, so now that we have these values, let's transfer them to our notebook. So let's go to the notebook that we have prepared. So the length was 12.49. The width was about 2.81. Let me just check. Yep. Okay, I recorded everything correctly. Now let's include the units of centimeters. And now from here, we're going to calculate the area. So area is the length times the width. So we're going to take 12.49 times 2.81, and these are both in centimeters. Don't forget the units. Now, just like any multiplication and division operation, we're going to count significant figures. The first number has 4 sig figs. The second number has 3 significant figures. Multiplying these numbers together, we're going to get a raw number value. So 12.49 times 2.81, and that gives us 35.0969. So we have 35.0969. And we're going to round this answer to 3 significant figures. So we find the third significant digit. We look 1 space to the right. 9 is greater than or equal to 5. So we round up. And that gives us 35.1 centimeters squared, because centimeters times centimeters gives us centimeters squared. Wonderful. So now you're going to collect data from another student's measurement. One of the tools that I recommend to do that is posting in the discussion forum and seeing if other students have shared their values in the discussion forum. Wonderful. So we have completed part B3. Once you have another student's measurements, you'll calculate the area using another student's measurements, and you'll discuss how why 2 students will obtain different values for the calculated area of the same rectangle. So you'll just answer this question. Given that there's going to be some variation, and given that there's inherently some variation when you take a measurement, you're going to see some variations in the area. Okay, so now that we've completed part B3, let's move on to part B4. So in this case, we're going to need some data from the Canvas page, but let's read some instructions for part B4 just to make sure that we understand what's happening. So let's go to the lab manual and let's look at B4. So we're going to record the shape of the solid object and the dimensions to measure. We're going to use a metric ruler to measure the dimensions of the solid in centimeters. And we're going to calculate the volume of the solid object in centimeter cubed. So there are a range of different objects you could measure the volume for. We could be dealing with a cube, a rectangular solid, or a cylinder. So let's look at the Canvas page and let's see what solid we're dealing with. Well, in this case, we are dealing with a cube. So we can use the simple formula where the volume is the length cubed. It is sort of funny, given that we have a cube, that we report the length, width, and height, considering that they're all identical. But because it's a cube, we only really need to take one of these measurements, as the rest of them will be identical. So let's take a measurement now. So again, just quick sanity check here. We need to figure out the value of a tick mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to go 10 ticks takes us 1 centimeter. In 1 tick, that corresponds to 1/10 of a centimeter, or 0.1 centimeters. We know that 1/10 of a tick, which is what we can estimate up to, corresponds to 0.1 centimeter over 10, which is 0.01 centimeters. Okay, so now that we have the bounds for how we're going to report our certain and estimated digit, let's now move on and take a measurement. Well, it looks like we're pretty much right on the 2.5 centimeter line. So we can write this measurement as 2.50 centimeters. Now, as you can see, if we look at the other side of this cube, we end up with pretty much an exactly identical result. Pretty much right on the line, so we could report the width as 2.50 centimeters. This makes sense. A cube has the same length, width, and height. Okay, so let's transfer that measurement now into our lab notebook. So for the shape of the solid, it's cube. So the dimensions to measure, so we're just going to be measuring the length. The length, width, and height are all going to be the same, 2.50 centimeters, 2.50 centimeters, 2.50 centimeters. So the formula for the volume, we can use length cubed in this case, or we could also write it as length times width and times height. Both are applicable. These are identical for a cube. So plugging in the length, width, and height, we have 2.50 centimeters times 2.50 centimeters times 2.50 centimeters. We see that our input has 3 significant figures. So our final value, we would expect to be reported with 3 significant figures. So if we have 2.50 times 2.50 times 2.50, that gives us 15.625 centimeters cubed. But we aren't done. We find our third reported significant digit. We look one space to the right because 2 is less than 5. We round down, and that gives us 15.6 centimeters cubed. Wonderful. So we've completed part B4 and we showed our full calculation. Keep in mind your measurement may be a little bit different than mine, and as a result, your calculated values may be a little bit different. That is perfectly okay. Okay, so now let's move on to part C, which concerns equalities and conversion factors. So in this case, we're going to need to read some instructions. So let's go to our lab manual. Let's see what's happening here. So for part C1, we're going to observe the markings on a 1 liter graduated cylinder, and we're going to write an equality that states the number of milliliters in 1 liter. Okay, so to observe a graduated cylinder, we're going to go to part C1, and here we have a graduated cylinder. This is a 1 liter graduated cylinder, and here are the markings. So let's take some measurements now. We see that in 1 liter, this 1 liter graduated cylinder, the 1 liter mark also corresponds to 1,000 milliliters. So here we have an equality, and we can take this equality and we can write it in the form of a conversion factor. So let's do just that. Okay. So we know in 1 liter, there are 1,000 milliliters. So there are 2 ways to write this. So we're going to set up a numerator and denominator. So we know in 1 liter, there are 1,000 milliliters. But we also know that in 1,000 milliliters, there's 1 liter. So the way that you write a conversion factor is you take your equality and you pick one of the quantities and you put in the numerator on top, and you take the second quantity and you put in the denominator on the bottom. All of these conversion factors are just equal to 1. And there are multiple ways of showing how, as we convert from one unit of measurement to another, the quantity remains unchanged. The only thing that changes is the number and the unit. Okay, so let's take a look at part C2 now. Again, we're going to go to the lab manual. C2, in this case, using a 1 pint or 1 quart measurement, measure 1 quart of water and transfer it to a 1 liter graduated cylinder. Record the number of milliliters in 1 quart, write the true equality, and write 2 conversion factors. Okay, so let's now check the lab page. In this case, we have an alternative procedure. In this case, we're asked to find out the number of milliliters in 1 quart and write the 2 conversion factors for that equality. Okay, so where can we find these conversion factors? You can check the notes, or we can check the lab manual. And in this case, the conversion factor is 1 quart is 946 milliliters. So now we're going to take this equality and write it as a conversion factor. So we know in every 1 quart, there are 946 milliliters. And we also know that there are 946 milliliters for every 1 quart. You don't have to worry about the question in this case because we're not going to be measuring. We didn't measure the equality in this case. We just looked it up and used it to write some conversion factors. Wonderful. So we completed part C2. Let's move on to part C3 and let's check the instructions for part C3. So we're asked to measure the vertical length of a page in inches and in centimeters. We're then asked to divide the number of centimeters by the number of inches to give the relationship of centimeter per inches. We're going to round off to give the experimental factor. Now, it appears the lab manual has a typo. We're asked to write an equality not for milliliters in a quart, but for centimeters per inch. We're then going to write 2 conversion factors for the equality. So let's take a look at the Canvas page, as that contains all of the data that we're going to be using. And in this case, we are asked to measure the vertical length of the page in inches and centimeters. So let's do just that. So first and foremost, let's start with centimeters. So this is the same centimeter ruler that we've seen. So we know that 1 tick is 0.1 centimeters and 1/10 of a tick is 0.01 centimeter. Again, this is the same ruler that we've used before. So the graduated marks are the same. The estimated digit is going to be the same. Okay, so let's see. So we're past 14. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we're pretty much spot on at 14.80 centimeters. Okay, now let's look at the inch part of the ruler. And for this one, I want you not to worry too much about the significant figure reporting for the inch side of the ruler. And you'll see why in a moment. So in this case, to go from 0 to 1 inch, so in 1 inch, there are 1, 2, 3, 4, 5, 6, 7, 8 tick marks. So 1 tick corresponds to 1/8 of an inch. And this is a little problematic, but let's write this out in a number form, because writing it out as a fraction is a little bit cumbersome, to say the least. So 1 tick is 0.125 inches. And now this is a little bit more precise than what these tick marks are actually representing, but we're going to err on the side of caution and over-report digits, so that way we don't lose significant figures when we try to calculate out our conversion factor. So we're past 5. We're 5, 1, 2, 3, 4, 5, 6. So we are somewhere between 5 and 6/8 and 5 and 7/8. Okay. So I'm going to say that it's somewhere in between those two values. And let's rewrite these values in something a little bit more simple to process. So what we're saying is it's somewhere between 5.75 inches and 5.875 inches. And in this case, we're going to estimate the last reported digit, and anywhere between 5.75 and 5.87 is more than acceptable. I'm going to report this as 5.80 inches. You're going to see a fair amount of variation in your inch measurement. That's more than fine. So now that we have these two values, we can now begin to calculate our experimental conversion factor. So let's transfer this to our lab manual. So the vertical length of the page, we measured it as 5.80 inches. And let me just check, 14.80 centimeters. Okay, so now we're ready to calculate an experimental equality. So we need to figure out how many centimeters are in 1 inch. So the way that we do that is we just take our centimeter value, which is 14.80 centimeters, and divide it by the inch value, which is 5.80 inches. Our final answer is going to be rounded to 3 significant figures because the bottom number only has 3 significant digits reported. So let's calculate that. That in turn gives us 2.5517 centimeters per inch, which we're going to round to 3 significant digits, which would be 2.55 centimeters per inch. Now, this is pretty good. This is relatively accurate. So we know for our experimental value that there are 2.55 centimeters per inch. In terms of the true equality, let's find that. Let's go to our lab manual. So what's the true equality in this case? Looking at length, We see 1 inch is 2.54 centimeters. Wonderful. Okay, so let's write the true equality. In 1 inch, there are 2.54 centimeters. To write these equalities as conversion factors, all we have to do is pick one quantity, place it on the top, so 2.54 centimeters per 1 inch, and we could repeat this process by writing the inverse, where in 1 inch, there are 2.54 centimeters. So with that, we've completely filled in part C3 for conversion factors involving length. Let's now take a look at part C4, which concerns unit conversion factors involving mass. So again, anytime we are encountering a component or part where we need some additional instructions, let's read the instructions from our lab manual. So in this case, we're asked to write the name of the commercial product. In this case, you're going to see a photo of a commercial product with a weight in ounces and grams. We're going to record the mass of the content in grams and the weight in ounces or pounds. If the weight is given in ounces, convert it to pounds. And then we're going to divide the mass in grams by the product weight in pounds. This will give us an experimental factor for grams in 1 pound. We're then going to write an equality that states the number of grams in 1 pound, and we're going to write 2 conversion factors. Okay. So let's go to part C4, and in this case, we have a photo of a common cereal container. So let's write down our measured values. So in this case, we're just going to transfer these directly to our lab manual. So let's just fill that in. The name of the commercial product is crispy rice. Okay, the mass in grams is 284 grams. The weight in pounds, it's not given in this case. So we see instead a weight in ounces of 10 ounces. Okay. So to convert, we know for 10 ounces in 1 pound, there are 16 ounces. Again, where did I get that information? If we look in the lab manual, in the instructions, it says 1 pound corresponds to 16 ounces. Okay, so punching that into our calculator really quickly, 10 divided by 16 gives us 0.625 pounds. And in this case, we're going to retain as many digits as possible. This 10 as reported is likely reported with a decimal point implied at the end. So if you really wanted to be super precise in your calculation, you could round this to 2 sig figs. But I prefer not to round until the end because I don't want to lose accuracy in my ending calculated value due to rounding error. So I'm just going to report this as 0.625 pounds. And from here, we'll be able to calculate our experimental factor. So we take our grams, which is 284 grams. Let's write that clearly here. And we divide by the weight in pounds, which is 0.625 pounds. Again, both of these values have 3 significant figures, so our final answer should be rounded to 3 significant figures. So we have 284 divided by 0.625, and that gives us 454.4 grams per pound, which we round down to 454 gram per pound. Now, let's look up the true equality. So let's go to our lab manual and let's go to that wonderful equality table for mass. And we see 1 pound corresponds to 454 grams. One pound corresponds to 454 grams. So we're pretty close to the true equality value. And if we compare our experimental value to the true equality, they're pretty much identical. So for the last part, let's write out some conversion factors. So we know that there are 454 grams in 1 pound. And we also know that in 1 pound, there are 454 grams. So we have our two conversion factors that we can write out. Okay, we're now ready to move on to part D, problem solving using conversion factors. Okay, so let's take a look at part D. Let's read the instructions for that. So in this case, we're asked to record our height in inches or use a yardstick. Using the appropriate conversion factor, we're then asked to calculate our height in centimeters, and then using the appropriate conversion factor, calculate the height in meters. So in this case, let's look at what data that were provided. So in this case, we're asked to record our height in inches, convert to centimeters, then convert to meters. And because we may not have necessarily a ruler available or a measuring tape available, I provided some data, in this case, a height value of 71 inches. So let's use that. Okay, so we have 71 inches. So in this case, to go from inches to centimeters, we use our conversion factor. So if we have 71 inches, we know that there are 2.54 centimeters per inch. Our value that we're converting to is on the top of the conversion factor. The value we're converting away from is on the bottom of our conversion factor. Inches cancel, and let's punch this value into our calculator. We have 71 times 2.54. That gives us 180.34. Again, this input has two significant digits, so our final answer needs to be rounded to two significant digits, which we round to 180. Remember, this placeholder 0 is not a significant digit. So we write this as 180 centimeters. Finally, to calculate the height in meters from centimeters to meters, if we have 180 centimeters as our starting point, we know that there are 10 to the negative second meters per every 1 centimeter. Centimeters cancel, and that in turn gives us 1.8 meters. So we've completed part D. You still have to answer these 4 post-lab questions, and I would encourage you to work through these questions independently and turn in your entire complete lab report along with all of the assigned questions answered and complete into the corresponding Canvas page. So with that, we've completed our run through of the Chem 100 experiment 2, and you'll see this full completed set of report sheets posted on Canvas as well for students to reference as a guide. As a reminder, all of the measurements you take should be taken independently. This video run through and the report sheets are just meant as a guide to help students check that they're completing each part of the lab properly and formatting their responses properly. So that concludes the run through of Chem 100 Experiment 2.